is Sohail, and I have invented a robotic glass cleaner. The purpose of my invention was to aid my father clean our living room windows because he suffers from back and knee pain. My ultimate aim for my robot is to develop it to clean high-rise buildings. Through my research, I have found that many lives have been lost due to high-rise window cleaning accidents. This gave my robot greater purpose. The first prototype of my robot was a success, but it left lots of room for improvement. In my last video, I mentioned some of my future development ideas that I would add to my robot. On completion of my first prototype, I began designing the second. Now, there's a new one. Version 2 of my window cleaning robot is a refinement of the original version. It is a mechatronic device which consists of a mechanical system, a pneumatic system, and an electronic system which work together to clean the window. One of the major changes in version 2 is a complete redesign. I split the device into two units, a cleaning unit and a control panel. By placing most of the passive components in the control panel and leaving only the active components in the cleaning unit, it dramatically reduces the weight of the device and allows for a more efficient and compact design. Here's how it works. The robot uses vacuum to stick to the window. This vacuum is generated by a vacuum generator located in the control panel. It takes in compressed air and creates a vacuum in one terminal. This vacuum supply is then connected through solenoid valves to 8 suction cups on the robot. The solenoid valves turn on and off the vacuum supply for each individual arm of the robot. When the robot is climbing, the horizontal arm is stuck to the window and the vacuum supply for the vertical arm is turned off, and it is moved upward by a DC motor connected to a rack and pinion. When the vertical arm reaches the end of the track, the suction cups are lowered onto the window by a pneumatic cylinder that fills up with compressed air and pushes a metal plate down. The vacuum is then turned on for the vertical arm and turned off for the horizontal arm. Now the DC motor spins in the opposite direction and the main body is moved up the track. The vacuum is then swapped back to the horizontal arm, and this cycle continues to produce the robot's movement. The robot can move upward, downward, left or right using this technique without having to rotate to face the direction of its movement. The mechanical and pneumatic components of the robot are controlled by the ATmega128 microcontroller, which I have created a custom circuit board for to house all the necessary electronic components. The microcontroller and the electronic system are the brains of the robot. Initially, the robot starts in the bottom right corner of the window. It climbs upward until it detects the top edge of the window. In my first prototype, the robot would detect the edge using a micro switch, but in version 2 it uses ultrasonic distance sensors. This is just one new feature in version 2. Then the right squeegee is lowered, and as the robot travels left, the squeegee cleans the window. This cleaning technique is repeated with the left squeegee being lowered as the robot travels right. When the robot reaches the left edge of the window, you will notice on the LCD screen that the robot has calculated an approximate area and drawn an approximate map of the window. As the robot proceeds to clean the window, it will actively display its cleaning progress on this map. In addition to this, there are also a few more new features in version 2. The control panel has gauges to monitor the pressure and vacuum levels in the system. In the first prototype, the DC motors spun at 32 revolutions per minute, but in version 2 they spin at 150 revolutions per minute, making it approximately 4 times as fast. I have replaced the 20x4 character LCD with a new 128x64 graphics LCD. The single squeegee is now replaced with 2 squeegees on the horizontal arm that use microfiber pads to more efficiently clean the window. This also eliminates the need for a water tank. You simply remove the microfiber pads and lightly spray them with a window cleaning agent. Then place them back on the robot and it is ready to clean. The microfiber pads are also machine washable. Although version 2 is complete, my robotic glass cleaner's journey does not stop here. I plan to develop a mechanism for my robot to climb from one window frame to the next, and I also plan to develop its software to make it smarter and more reliable.